Hi, in this video, we are going to see how to use plot command in MATLAB to generate a 2D figure. And then, at the later part of the video, we are going to see how to edit the plot, add labels and titles, and also how to change colors to the plot easily without doing any coding in the script. So let's begin. So I already opened MATLAB and I have saved the script in the name. And I have put this CLC clear all and close all commands. This close all command is there to close all the figure windows that's been opened. So this will help us to reset the figures that's been generated. And CLC is for clearing the command window, and clear all is for clearing all the memory space. All right, so let's begin. So to plot a 2D graph, we need two data sets. One is in the x-axis and one would be for the y-axis. So let's generate a data set for x-axis. I'll define a variable x for that. You can define another name if you want. Now let's just say the variable x should be from 0:5. If you don't know what it does, I have another video that talks about how to generate arrays. So this will necessarily generate 0, 1, 2, 3, 4, 5, 6 elements in the x-axis. And I put a semicolon to suppress the output in the command window. Okay, so I'll put another data set for y. Let's just manually define it so that we can see what data points are we defining here. So I'll say the first one, say 0.1, say 0.5. We need 6 data points because we have 6 data points in x-axis. So always remember that the number of data points in x-axis has to be exactly the same as number of data points in the y-axis to generate the plot. If you have, if you don't have that same number as same, then the plot will not generate. It will show error. Okay, so let's say 0.2 and another 3. Okay, so I have I'll just omit the semicolon to show you guys. So if I just run it, so I have x as 0, 1, 2, 3, 4, 5. So there's 6 elements here. And I have y as 0.1, 0.52. So I have manually defined the y values. I'll put semicolons here just to suppress these. And you can see these have been saved in the workspace. Okay, so how to plot this? We'll just use the command that's called plot. If you want to know how to define plot, you can say help plot and type enter. And here you can see there's a lot of definition and how to syntax of how to use the plot command. So this is a linear plot and there's a lot of things. So we'll use this as plot x comma y. So I'll just come here, type plot, and if the first one, as you can see, it shows the x-axis value, as in this case we have x data, comma, and the second position is for the y-axis value, which is y in this case for us. And if I close the parenthesis, and now if I just type press and run, and then you can see the figure has been generated, and the name of the figure is figure 1 by default. So as you can see, this has x-axis, y-axis, and the figure has been generated. As I haven't defined anything for the plot, it plotted with a default setting. One thing to notice is that if you put only the y value instead of x comma y, it will still plot it, but instead of taking any x value, it will take the index of x values, meaning it will start from 1 for the first data set and go up to the last data set. So in this case, it will go from 1 to 6 if I just run it. And you can see it starts from 1 x-axis and goes up to 6, but the y-axis, y data points remains the same. So we'll use the x comma y here. I'll do this again, run it, and this is our figure that we want. Now you can see this figure doesn't have any labels, any titles, or we don't know how to change this. Like this is the default setting, a blue one, and the line we might want to have a different line or different types of markers and so on. So in this part, we are going to see how to edit this plot without typing any command and using this property inspector. So as you can see on top, there's a lot of options here. So the first one is new figure, open file, save figure, and we come to this part where it says open property inspector. So if you just click on that, it will open this new window of property inspector. Now, the first we are going to see how to edit the plot itself. So let's just click on here. So we can click on any part and you can change it. So right now it's the axis is selected. You can see figure 1 axis. So we can change the axis properties. If I select the line or the plot itself, you can see the line came up. So now we can go to this interactive property inspector and change the plot as necessary. We don't have to change the script as we have already generated the figure. We can change it from here. So let's see how to change it step by step. So first we have clicked on this. Now you can see this, the first thing it says colors and styling. So the default is blue. We can come here, click on the drop down menu, and you can change anything you want. So if we just select this one, and it changed to that orange. And the second option is line style. It says align. We can select this one, might be dot dash, that dot dot, and so on. So there's a lot of options that we can select from here. The other thing we can select is line width. So it will control the width of the line. So if we want to increase that, instead of 0.5, let's have 2, and press enter, and you can see it just generated the line width of 2. And like this, we can actually control the plot from color and line styles from here. The second part is called markers. What is a marker? Markers are the markers for the data points, meaning it will show a symbol for each data set we have. For instance, here we don't have any markers selected as none, so we can select any marker we want. Let's say we want to put a plus sign in at any data point we have. So if I just select that, instead of having none, it will have plus signs here. And then we can say marker indices. It controls the indexes of these markers, like where the markers should be. And we can have control over marker size, so we can increase or decrease it. So let's say instead of 6, let's say we have 10. Now what happens is that if I just click anywhere here, you can see the markers as plus, and it's also the same color. If I click on that plot again, go to the marker, and here from marker edge color and marker face color, we can select different colors for this marker, different than the plot itself. Now you can see we have a black marker and so on. So if I just select here, we come back to this exact same function, and from this we can change the color of the line, style of the line, line width, and also marker type of markers, marker size, and marker colors. There are other options, like we can select the data points, X data and Y data, and we can select legend for having multiple data points in one single plot. We don't have it. We have only one data set, so we won't use a legend here. But this is how we can change the color and types of lines in this figure. Now let's just go to the axis and change the axis properties. Okay, so I'll click here, and that will select the axis. Now if I just select the first option, which says font, so this controls the font of the axis numbers. So as you can see, it's the font name, font weight. We can select bold or not bold font size. So we can click on here to, let's say we want a bigger font size. So let's say 15. If we click here, if I just bold it, you can see it just made it bigger. And we can do we can have many options for this. So we can go here, play around, and change the axis labels as necessary. And this is how we can actually change different fonts and font sizes and so on. Okay, and then the second option is the ticks. If we go here, if you open this, the X ticks changes or controls the display of the ticks. Ticks are defined as these small ticks in the axis. So as you can see, this is defined as 0, 1, 2, 3, 4, 5. So as it's showing 0, 1, 2, 3, 4, 5. Now, if we want to make it a manual and have another manual entry, we can say comma, we can add, let's say 4.5 we want to add manually, and if I click somewhere else, and you can see it generated a lot of ticks and tick labels. So if I do that, there's tons of options so that we can change X ticks and X tick labels from here. And then we can also change Y ticks and Y tick labels from here. So this is only to control how many ticks that we want to show in this plot. We can increase or decrease it depending on our data points. So that is for the ticks. Let's go to this rulers. The rulers are there for to show what should be the limit of the x-axis or y-axis. Meaning, if we want to change the range of this axis, we can change it from here. So let's say xlim defines the limit of the x-axis. So now, right now it has from 0 to 5. If we come here, click on this, we can say minimum is 0, but maximum we can change it, let's say to 6, and we can change the minimum to, let's say, -1, and let's say -1, and that way you can see the x-axis changed to a manual scaling from -1 to 6. And as you can see, the y-axis, the 3 is kind of cutting out here, so we can also increase the y-axis from changing the y-lim values. So instead of having 0, we can start from, say, like -1. Instead of max as 3, we can increase that to, say, 4. And if we do that, you can see we have kind of changed the whole plot, the scaling of the whole plot. So as we don't have a z-axis, because this is a 2D plot, in a 3D plot we would have a z-axis, and we can change that from here. So in this ruler part, we can actually change the scaling of these axes. Now we will see how to change x-axis location by using this option. So if we go down here, x-axis location, it says bottom. You can click on the drop-down menu. You can select the top. So instead of having on the bottom, the x-axis now goes to the top. You can also change it to the origin so that you will see it's kind of goes through the 0 point. And similarly for the y-axis, we can change it to right or origin. So depending on these options, we can select the ways we want to orient our x-axis and y-axis. And these are for the x color and y color. Now it's selected black, but you can change it to different colors, like this, like that, or whatever we want. And also for the y-axis, you can come here and change the color of y. There's another function that says x direction. So right now it's going from a normal direction from -1 to +6. We can reverse the order and show the biggest one first, so it goes from 6 to -1. So if we want to do that, we can do that from here. The other thing is that if we have a logarithmic scale in any axis, we can select it from here. So instead of a linear plot, we can say x-axis should be a log. If we do that, now you can see the x-axis changed to a log, and we can do similar things to y-axis. Now it's a log plot. So log in the x-axis, log in the y-axis. Now we go back to linear, and so on. So in this rulers, we change the axis positions, axis limits, and also axis orientations and colors. So now let's go to this next option, which is grids. So as you can see, we have multiple options. We can turn on X grid, so that turns on the rulers. We can turn on Y grid too, and that kind of signifies the grids. And also we have multiple options like layers, grid colors, and grid color mode. There's grid alpha that defines the transparentness of this grid lines, and so on. So there's also, we can turn on minor grids. So those are like minor grids that could be turned on. So depending on your need, you can change this to however you want, and you can change also the colors. So if we go to the next part, that's called labels, we can now add title, X label, Y label, or legend if we want. So now let's add a title here. If I just click on this text, you can see a title appear. Now, instead of title, we can say, let's say X versus Y graph. So this is my title, okay? Now if I do that, you see it's just generated that title. We can change the color of that title, and we can change the font, we can change the font size, and so on. Okay, we can do multiple things with this. So we can also change the text box position. So there's a text box around it. We can rotate it if we want. Let's say if we want to rotate it 45 degrees inclined, we can have that. So depending on what we need, we can change it to any position or any colors we want. So let's go back to the original X versus Y graph. So I come here, instead of text, I click on X versus Y graph, and now we come to this function. Now I need labels for X and Y axis. Let's click on this. So this is my X label, and we can name it whatever we want. Let's say the X-axis has a variable that's called time. Okay, so if I just do that, click anywhere you want, and this shows up time. Now you can change the fonts or font sizes for these. Like if I just increase it or decrease it, it will increase the font size, and we can bold it, make it italic, and so on. Okay, and we can also do the rotation here if we need, like 45 or 90, or if we put a -45, it will rotate in a different way. So depending on what data point or what plots we want to generate, we can change or edit these. You can play around and see how to edit these. Okay, let's go back to this again, X versus Y graph. Now we can say Y label, just click on the text that generated Y label, and we can add a, like, let's say Y label has amplitude in it, and if we click somewhere, it just generated that text. We can change the color if we want, and then we can change the font size and so on. Okay, so one thing to mention here is that in these labels we can also include symbols or mathematical operators. Let's say I want to include an alpha. So what we want to do is we can enter a / and then just type alpha. And if I do that, click anywhere, now you can see alpha appeared in the plot. So depending on what we need, we can change it. So now that we have generated our plot and edited so that we are satisfied with our titles, labels, and axes, now is the time to save this plot. How to save it? One way to save is to just click on the save. You can save figure, and that way it will pop up the option. You can change the save as type from here. The .fig is the default for MATLAB figure. You can change it to all other data, all other save as types or data types you want, file types. The other way, let's say you want to generate a report on a Word file, so you can come here, you can say edit, and you can say copy figure, and that way it will copy the figure and we can actually paste it in the Word document. The other ways to save or copy this plot is to, let's say if we come here, there's options that shows up. If we come here, it says the first one is saving this. The second one it says copy as image, so it will copy this as an image. And the third option is to copy as vector graphic. So a vector graphic meaning it will not change its resolution even if you zoom in or out. So let's just use this copy as image, and let's try it out in a blank Word document. I'll just open a Word document, and if I just paste it, as you can see, it shows up. Now I can change the size of it like this and so on. Okay, so let's go back to the MATLAB and do the same thing, but now we will copy it as a vector graphic and go back to the Word. Let's paste the same figure. Now the second one is a vector graphic, remember? Now you can resize it like the same. If I just zoom in, you can see there's a little difference between these two figures. So what I want to say is that saving it as a vector graphic sometimes might be beneficial because it won't change the resolution, but this is the easiest way to do it. So if we go back to the MATLAB, so this is our figure. You can save it as a PNG or JPEG so that this figure is not lost. So this is how we can plot in MATLAB, and without typing it in anything in the script, we have generated a figure and edited it so that it has titles, labels, axes, and so on. So in another video, we will see how to do these edits in a script by writing commands. And so you don't have to open this figure window every time and change these manually using the property inspector. That's it for now. Thank you for watching. See you in the next one.